get going on review problem number 6. Here you go. I think you can do this one. It looks scary, but it's really pretty simple. We are going to use data. Oh, we got a table here. Somebody's done a bunch of reactions and we're talking about kinetics. So what we're after, we've got this reaction here and we want to find the rate expression. Okay, so what we're looking for is rate equals to K times what? Okay, does it depend on the concentration of A or B or what? So we'll find out from the real data, and that's where the rate equation comes from. Remember, it comes from real data. Okay, and then the other thing, D is a catalyst. So let's look at what happened in between trials 1 and 2. What we did is, if you notice that we doubled the concentration of B, and what happened to the rate? It doubled. Okay, so we know that we had the same effect. If we double B, we double the rate. So is B in our rate equation? It is. So I'm going to go ahead and put it in there, and it's to the first power. If we got like a squared effect, we would square B, or square root effect, or so forth. All right, the second one, between trials 1 and 4, what we changed, we kept everything the same except for the catalyst. We doubled the concentration of D, and what happened to our rate? It doubled. Okay, so we got the same effect. So we know that the rate is also dependent on the concentration of our catalyst. All right, now what about A? So let's look at trials 2 and 3. Between 2 and 3, what did we do? Well, we doubled A and we doubled B. Okay, and so I'm going to say we doubled A and we doubled the concentration of B. And what happened to our rate? Well, it went from 1.29 to 2.58. It doubled. Okay, well, what was that the effect from? Was it from the A or from the B? Well, we already know it was from the B. Did the A have any impact on that? Did it affect the rate at all? It didn't. So A is not in our rate equation. It's a reactant, right? But the concentration of A does not impact the rate. So that's it. We've got it. Okay? We are ready to calculate the rate constant. All right, so that's how you use a table of data. Now, this is the fun part. You pick any trial that you want. Let's just do trial 1. And I'm going to take that data from trial 1 and plug it into my rate equation. So the rate, here it comes. The rate is 2.58. And that is molarity per seconds equals K, that's what I'm going to solve for, times B, the concentration here was 0.2 molar, and then the concentration of D was 0.1 molar. Okay, and when we solve for K, we get 130, and the units of this, these are kind of odd, molarity on the bottom and then seconds on the bottom. Okay, so that's our rate constant. So look what we did from real data. We derived the rate expression and we found the rate constant. Now, it wouldn't matter which trial that you used. You can plug in that real data to get the K, and you should get the same value.